Project planning is frequently misconstrued as a bureaucratic, time-consuming exercise that produces documents destined to gather dust. This perspective is fundamentally flawed. In modern project management, planning is a primary value-adding activity. It is the intellectual process of converting uncertainty into a structured, manageable course of action. The core purpose of planning is not to create a rigid, unchangeable schedule, but to think through the entirety of the project, anticipate challenges, and establish a baseline against which progress can be measured and controlled. This process is guided by the principle of progressive elaboration. A project plan is not created in a single session, but evolves over time. At the start, information is limited, so plans are high level. As the project progresses and more information becomes available, the plans become increasingly detailed. This iterative nature allows for flexibility while systematically reducing project risk. A well-planned project, even if the plan itself changes, is far more likely to succeed than a poorly planned one because the team has already contemplated the work, its dependencies, and its potential pitfalls. The project planning process can be understood using a classic input-process-output (IPO) model. It is a structured endeavor that transforms high-level directives into detailed, actionable plans. Inputs. These are the foundational documents and information that authorize and define the project at a high level. The primary input is the project charter, as discussed in Chapter 2, which provides the initial scope, objectives, and the project manager's authority. Other inputs include stakeholder registers and information about the organizational environment. Process. This is the core of planning, where the project management team engages in a series of integrated processes to define how the project will be executed, monitored, controlled, and closed. These subsidiary planning processes include scope planning, schedule planning, cost planning, quality planning, resource planning, communications planning, risk planning, procurement planning, and stakeholder engagement planning. Output. The primary output of this comprehensive effort is the project management plan. This is not a single document, but a formal, approved composite document that integrates all the subsidiary plans listed above. It is the master blueprint for the project, defining the what, why, when, how much, and who of the project. This plan becomes the performance measurement baseline against which the project's success will be judged. Managing the planning process itself is a project within a project. It requires a conscious effort from the project manager to ensure it is efficient, inclusive, and effective. Iterative nature. As established, planning is not a one-time event. The project manager must facilitate a cycle of planning, executing, and then replanning based on performance data and approved changes. Team involvement. The adage, "Those who plan the work the plan," holds true. Effective planning is a team sport. The project manager must involve the project team members in estimating durations and costs for their respective areas of expertise. This not only leads to more accurate estimates, but also fosters a sense of ownership and commitment to the plan. Establishing baselines. A critical outcome of the planning process is the establishment of formal baselines for scope, schedule, and cost. A baseline represents the approved version of the plan. Once baselined, the plan is subject to formal change control. Any deviation must be managed through a structured process, preventing uncontrolled changes from derailing the project. A plan is only useful if it can be effectively communicated. Graphical techniques are powerful tools for translating complex data into an easily understandable format. The most common of these is the Gantt chart. Developed by Henry Gantt, a Gantt chart is a type of bar chart that illustrates a project schedule. The vertical axis lists the project tasks, often from the WBS, and the horizontal axis represents time. Each task is shown as a horizontal bar, with the position and length of the bar reflecting the start date, duration, and end date of the task. Strengths. Excellent for communicating schedule information to stakeholders. Clearly shows task durations and progress against the plan. Simple to create and understand. Weaknesses. Becomes unwieldy for projects with hundreds of tasks. Does not clearly illustrate the logical dependencies between tasks. One cannot easily see which tasks must precede others. When a project's complexity grows, the limitations of the Gantt chart become apparent. To manage a project with numerous interdependencies, such as a large-scale infrastructure project like the Delhi-Mumbai Industrial Corridor, a more sophisticated tool is needed. This tool is the project network diagram. A network diagram is a graphical representation of the logical relationships or dependencies among the project's activities. It is the foundation for schedule analysis, allowing the project manager to identify the project's critical path and understand how delays in one area will impact the entire project. There are two primary methods for creating network diagrams: activity on arrow, AOA, and activity on node, AON. The activity on arrow, AOA method, also known as the arrow diagramming method, ADM, is a historical network diagramming technique. In this method, arrows represent the project activities. Nodes, typically circles, represent the start and end points of activities, known as events. A key feature of AOA is the use of dummy activities. A dummy activity is an activity with zero duration, represented by a dashed arrow. It is used to show a logical dependency when one does not otherwise exist, or to ensure that each activity has a unique start and end node. The reliance on dummy activities can make AOA diagrams complex and difficult to draw. Regardless of the diagramming method used, the purpose of a network diagram is to perform critical path analysis, CPA. This is an algorithm for determining the shortest possible time in which a project can be completed and identifying the sequence of activities that dictates this duration. The critical path is the longest path through the network diagram. The activities on this path have zero float or slack, meaning any delay in these activities will directly delay the project's completion date. The CPA algorithm involves two passes through the network. The forward pass. Starting from the first activity, we calculate the earliest start, ES, and earliest finish, EF, times for each activity. The ES of an activity is the latest EF of all its predecessors. The formula is EF equals sign ES plus duration. The backward pass. Starting from the last activity, we calculate the latest start, LS, and latest finish, LF, times for each activity. The LF of an activity is the earliest LS of all its successors. The formula is LS/LF duration, calculating float, slack. Float is the amount of time an activity can be delayed without delaying the project's completion date. It is calculated as float LFF or float LSES. Identifying the critical path. The critical path consists of all activities where the float is zero. These are the activities the project manager must watch most closely. The activity on node, AON method, also known as the precedence diagramming method, PDM, is the modern and predominant technique for network diagramming. In this method, nodes, typically rectangles, represent the project activities. Arrows show the logical dependencies between the activities. AON is more flexible than AOA because it does not require dummy activities and can represent four types of dependencies: finish to start, FS, finish to finish, FF, start to start, SS, and start to finish, SF. Due to its flexibility and ease of use, AON has become the industry standard. CPA is a deterministic model. It assumes that activity durations are known with certainty. However, in many projects, especially innovative or R&D projects, duration estimates are highly uncertain. The Program Evaluation and Review Technique, PERT, is a probabilistic model designed to handle this uncertainty. PERT uses a three-point estimate for the duration of each activity. Optimistic, O, the best-case scenario duration. Most likely, M, the most realistic duration. Pessimistic, P, the worst-case scenario duration. From these, PERT calculates an expected duration, E, using a weighted average formula, E equals sign O plus 4M plus P/6. This expected duration is then used in the CPA calculations. Furthermore, PERT allows us to calculate the variance, S2, and standard deviation, sigma, for each activity's duration, which indicates the degree of uncertainty, S/PO/6 and S2/PO/62. By summing the variances of the activities on the critical path, we can calculate the standard deviation for the entire project. This allows the project manager to answer questions like, what is the probability of completing the project by August 15th? This is particularly valuable in contexts like India, where factors such as unpredictable monsoon seasons or complex regulatory approvals can introduce significant uncertainty into project timelines. Before diving into detailed network diagrams, it can be useful to create a high-level strategic plan. Four Fields Mapping is a visual planning tool that helps align the key dimensions of a project on a single page. It consists of 4 quadrants: goals, why, the objectives and desired outcomes of the project, activities, what, the major blocks of work or deliverables required, responsibilities, who, the key individuals or teams responsible for each activity, timeline, when, the major milestones and target dates. This tool facilitates strategic conversations and ensures that all team members have a shared understanding of the project's purpose and structure before detailed planning begins. Scenario: a fast-growing Indian e-commerce company in Bengaluru has historically allowed its project managers to use their own planning templates and software. As the company scales and projects become more complex, the new head of the Project Management Office, PMO, proposes mandating a single standardized planning methodology and software suite for all projects. The argument for standardization: the PMO head. A standard approach ensures consistency, facilitates easier reporting to senior management, allows for better resource allocation across projects, and creates a common language for all teams. It introduces a necessary discipline that will improve predictability and reduce project failure rates. The argument against a senior project manager: a rigid, one-size-fits-all template stifles innovation. An agile software project has different planning needs than a marketing campaign or a warehouse expansion project. Forcing everyone into the same mold is an unnecessary constraint that will add bureaucratic overhead without adding value, slowing down the very agility that made the company successful. Lesson: the debate highlights the central tension between control and flexibility. The optimal solution is often a hybrid one, establishing a standard framework and language, but allowing project managers the flexibility to tailor the specific tools and level of detail to the unique needs of their project. In the late 1990s, Prudential Corporation undertook a monumental project, moving its corporate headquarters and over 1,000 employees from London to a new purpose-built facility. This was not a construction project, but a massive logistical and organizational change project. Context: the project involved coordinating hundreds of vendors, managing the decommissioning of the old site and the commissioning of the new one, and most importantly, managing the human element of the move. The entire business had to be shut down on a Friday in London and be fully operational in the new location on Monday morning. Planning challenges, dependencies. The project was a web of thousands of critical dependencies. The IT servers couldn't be moved until the new server room was complete. Desks couldn't be installed until the carpets were laid. Employees couldn't be trained on the new phone system until it was installed. Uncertainty. What if a key supplier was late? What if a moving truck broke down on the motorway? What if the IT systems failed to come back online? Application of planning tools. This project is a perfect illustration of the power of the tools discussed in this chapter. CPA would have been essential to identify the critical path. The sequence of activities related to moving the core IT data center would almost certainly have been on the critical path, as any delay here would have been catastrophic. PERT would have been used to model the uncertainty. The project manager could have used 3-point estimates for high-risk activities, for example, the time to restore the core database from backups, to calculate the probability of being fully operational by Monday morning, and to develop contingency plans for high-risk scenarios. Lesson: the Prudential move demonstrates that even a project with a fixed, unchangeable deadline requires sophisticated planning. The value of network analysis lies not just in finding the critical path, but in understanding the project's vulnerabilities and systematically managing the risks that could threaten its success. As we conclude, remember that project planning is an intellectual journey. We've traveled from the philosophy of planning as a value-adding activity to the detailed mechanics of CPA and PERT. We've seen through case studies that planning is not a sterile exercise but a dynamic human endeavor that must adapt to its context. The enduring value is in the intellectual rigor. The thinking is more valuable than the plan. This rigor provides the confidence to lead, to manage change, and to transform a vision into reality. This module is the end of the beginning. Mastery is a continuous journey of lifelong learning. Apply these skills, be curious, learn from others, and cultivate a habit of reflective practice. Projects are the engines of human progress. By mastering this discipline, you are choosing to be a builder of tomorrow's world. Go forth and plan with rigor, lead with purpose, and build with confidence. The future is an unwritten project, and it is waiting for you to draw up the blueprints. This concludes our module on Master Project Planning.